Good day, everyone. So my name is Syukri, which will give a brief introduction regarding TCP/IP protocols, switch such as HTTP, DNS, Telnet, and SSH, FTP and TFTP, and DHCP. So throughout this presentation, we'll explore how these protocols works, and we will implement them in a network setup using a software like InterNetSP or Cisco, and with Wireshark for traffic analysis. So without further ado, let's start with the first protocol, which is HTTP.
I'll be talking about the HTTP protocol. So over here, we have the configuration, the topology. I have one server, one router, and one client. So the router connects the server and the client together, despite they are on different networks through static routing. So for the server, I have the local address 192.168.1.2, and the gateway is 192.168.1.1. Subnet masking is 255.255.255.0. And meanwhile, for the client, we have the local address is 10.10.10.2, gateway is 10.10.10.1. The subnet masking is 255.255.255.0 as well. So right now, what I'm going to do with the client is I am going to do packet capture through Wireshark so we can see how the packet is being transferred. So first we have to start this. This is my root path, the directory of the files which I want to transfer through HTTP. So I will start and I will go over to my client. Okay, and I'll hit go. So here we are getting prompted to save the file, which is test.html. So I'm going to save it as test. Take a look at this. And here we go. The HTML file can be opened. If we take a look at Wireshark, over here we can see the request header and the response header. This is get. This is okay over here. That's all from me. Thank you very much.
Hi guys, today I'll be explaining about FTP and TFTP. So over here, we have two routers act as a client and server, which is R1 and R2. Okay, for the first one, over here we have configuring Huawei router IPs. This is a command line interface to assign an IP address to an interface. So let me show you here's a step-by-step explanation for the commands and output. For the first one over here, we are entering the system view. System view, this command is used to enter the system view mode where you can configure the device. And for second one, we are setting the system name, which is sysname R1. This command sets the name of the router to R1. Thirdly, we are entering interface views, where this is called int d1001. This command enters the interface view for the Gigabyte Ethernet 001 interface. And this could assign an IP address where IP address is 10.0.12.124. This command assigns the IP address of 10.0.12.1 with a subnet mask of 255.255.255.0 denoted by 24. After this, we are exiting the interface view, where this command is likely intended to exit the current view. However, the correct command should be quit to exit the interface view properly. For number 6, there are system messages over here, where it read it as data sync s_cf_change.otd, where these indicate that the line protocol on the interface Gigabyte Ethernet 001 has entered the upstate, meaning the interface is now active. This message shows that the configuration of the router has been changed. And for the R2, it's the exact same explanation. So I don't want to explain more. And then let's continue with the second one. This connection is successful. How do I know that? Is by the command ping 10.0.12.2 is used to check the connectivity to the IP address of 10.0.12.2. Where the ping results here over here, the reply shows successful communication with no packet loss and various round trip times, where minimum and average and maximum are 10 meter per second, 30 meter per second, and 60 meter per second. For the next one, we are enabling FTP server and set file directory. This is where FTP server enabled and starts the FTP server. These logs indicate the server started successfully, and these create a FTP user access to the AAA, which is authentication, authorization, and accounting command mode. Local user over here has a Huawei password triple called password triple Huawei 123. Creates a local username Huawei with password of Huawei 123. This local user Huawei service type is FTP. This sets this user service type to FTP and assigns privilege level 3 to the user. Directory flash offsets the user's FTP directory to the flash memories. For the next one, we are listing the directory contents of the flash. This saves the current configuration to the device, prompt the user to input a file name for the configuration, where it is filed as .cfg and .zip. The configuration is saved successfully with the file name of vrpcfg.zip, and another direct command lists the uploaded contents of the flash directory showing the newly saved configuration file of vrpcfg.zip. Over here, this is the same as just now I've been told, which is connecting the FTP server to from RL1 and creating file and checking new file is transferred successfully. That's all from me, guys. Thank you.
My name is Hafiz, and I'll be describing how to set up the telnet protocol in ANSP. So first we need to grab two switches and connect them via gigabit internet like shown. Now we need to assign an IP address to the first switch, which I did 192.168.1.1. And here you can see I accessed the int VLAN 5 interface, and then I assigned the IP address. Now what we need to do is set the authentication mode so that we can create a user and only we are able to access the terminal. So here you can go into the user interface console 0 as well as the VTY lines and set authentication mode AAA. Now we need to prepare the protocol to the server to actually take the protocol telnet. Here we can do this by protocol inbound telnet. Now we need to actually enable the server, and here you can see you just put telnet server enable, and then you need to create a local user. Here I created Huawei LSW1 and then Huawei 123 as the password. Now you want to set up an access port. You enter port link type access and port default VLAN 5. Now what you need to do is assign an IP address to the second switch. Here I assigned it as 192.168.1.224. You just need to repeat the steps that we did for the first switch, and that's how we set up the environment. So again, we need to also set up the authentication mode AAA, user interface console 0, and the VTY lines. We also need to set the authentication mode to AAA, and then prepare the switch to take in the telnet protocol. Now we need to again enable the server, and then we also create a local user, telnet LW2 and telnet password telnet123. And then we also need to set the service type as telnet, since that's the switch we're trying to access from switch 1. Now we need to set up the access port, port link type access, port default VLAN 5, and that's the connection has been set up. You can check the connection by pinging the first switch at IP address 192.168.1.1. As you can see, the packets are received and transmitted properly. Now we need to connect the telnet server, so telnet and then this IP address of your second switch. And then what you need to do is log in using the account, the user that was created using the telnet service type. Here I use telnet LW2 and whatever password you used. And as you can see from the first switch, we have access to the second switch. Now for the SSH protocol, we need to set a connection between a PC and a router. You want to set the IP address to the PC, such as 192.168.1.2.1, and then the IP address to the router, such as I used 192.168.2.2. And you can check the connection. As you can see, packets are received and transmitted properly. Now we need to generate the keys, which will encrypt data. You can put RSA local key pair create, and then for how many bits you want to assign to the keys, and that will generate how many keys based on how many bits you put here. Now you need to create a user so that you're the one that can access it. And here I created Huawei 123 as the password. And then you also need to set up the service type, which is type SSH, since that's the protocol we're using. Now you need to also set the authentication mode, and you also need to enable this telnet server so that we can actually communicate via the telnet protocol. You also need to do now is you can check the configuration was set up properly. The protocol inbound SSH, so it will communicate, the PC and the router will communicate, and your data will be encrypted via SSH. Thank you.
All right, thank you. Now I'm going to present on my protocol DHCP, which stands for Dynamic Host Configuration Protocol. Basically, what it does is that it's a protocol that assigns an IP address to a client that requests it. So we see ANSP here. What I did is that this is a basic setup of the DHCP server. What we do is to set up, first of all, we enter system view and enable DHCP. Then we create IP pool and name it. I've created a proper one here. And then we can configure it by pressing question mark and hitting enter. We can see the various commands we can use to configure it. First, I set the network gateway list and use Google DNS list. We can also configure how long the client can own that IP address using least day 3 and 4 hours. Then I use exclude IP address to exclude this IP address so the server does not assign it to anyone. Next, I quit and then configure the interface for the router as per usual. Then I use DHCP select global since I already configured the IP pool up there. You can use interface to access the DHCP server and configure it on the interface, or you can use relay, which is the third one, which is to set up something like this. The setup is more or less the same, but this has a few extra steps in between. Next, we quit and then start capture with Wireshark. As you can see, PC4, we can use the tool IP config to check the IP address. In this case, it's .253. PC5 is .254. We can see if it's working or not by pinging the router, and I ping 254, and Wireshark was able to capture it. As you can see, to the router, the ping worked, and to PC5, which worked, means the IP address is being used correctly. Next, we can use DH client by these two commands, /release and /renew, for the client to release the IP address, and they go back to their default IP address, and to renew is to request a new IP address from the server. So Wireshark was able to detect the release, and finally, the 4 steps are that PC4 is sending a broadcast to say, yes, hello, I want an IP address, please, which DHCP picks up and offers this IP address to the client, and then the client broadcasts saying, yes, I do want that IP address. And DHCP acknowledges the request and then assigns this IP address to it. Finally, we can check the IP address by using display IP pool to see all IP pools. And for a better view, we can use display IP pool name, and then we can see stuff like the list and the DNS server. As you can see, the total is this. We use 2 for the PCs. These many are idle, and 1 has been disabled because we excluded it just now. That's it from me. Thank you so much.
In this presentation, we will learn how to set up a network with DNS. So let's see what are the devices we have in this DNS setup. So as for the first devices, I have 2 PCs and 1 server. And as for the network devices, we have a switch. DNS is called domain name system, which is like a phone book for a networking. And so to set up a successful DNS setup, we need to configure the server first. As you can see, we have a DNS server IP address, and the next thing we should do is that IP configuration. As you can see, the IP address is just same as the DNS server address, 192.168.11, and the subnet mask is just the same, 255, as for every single devices, and it's also the same IP address for the DNS server. The next thing we should do is we need to go to services and click on HTTP, save it, and like it says override. And the next thing we should do is the DNS, and we need to add some IP address and its name. So as you can see, I created a name by example by my website, and then a PC1. So we need to add it, and we have IP address for each and every devices. So that's the next thing. So as the next thing, we should also configure the PC. As you can see, I have configured it 192.168.1.2, and the subnet mask is just same one as everything else. And the next thing is the DNS server, as the DNS server should be same as the before this, because it's using the DNS server IP address, and then we need to configure it, and it's just the same. And then after that, we need to also configure our second PC, which you can see 192.168, which is the IP address. And the next thing is that the subnet mask is just same for every single devices and the DNS server address. The next thing we should do is we need to test it whether it's working or not. So we go to command prompt and ping my website. As we can see, as we can see here, the packets sent is 4, received 4, and lost 0. So this shows that our our setup is working. And the next thing also is that try to look up in ns look, which we can try in the second PC, which is command prompt. We can actually write a command named ns lookup my website, which shows their server and their address. So shows that the name of the website and its IP address. This shows that our DNS setup is working. And to create a website like this, we don't need much of things to do. And that's all from me.